Hi everyone. Today I'm going to go through a problem called My Travel Planner. I've been using this problem for an introductory Java course for the last couple of years, and I like this problem because it introduces the reader or the person doing the exercise to several different concepts. One, test-driven development, which is an important concept in software engineering, and also to top-down design, decision trees, and also it's infinitely extensible. You can hook it up to an API to create a software as a service platform, or you can create a GUI on top of it. But in a sense, it starts at a very basic level, but then you can extend as you want on top of it. So let's get started. So here are the requirements for the problem that I'm considering. I need a program to help me plan my travels to appointments in the city. Consider the following facts and preferences. I live in the suburbs. Schedule of trains from the city to from the suburbs are as in the table below. There is a first train, there is a last train, both ways from the city to and from the suburbs, and the train interval is different for weekday and weekend. And assume that it takes about an hour to drive or take the train from the suburbs to or from the suburbs. And I prefer to take the train rather than drive when it's practical. But if it's not practical, then I would need to drive. I prefer not to drive if there is rain or snow. I'd rather reschedule my appointments. The program is going to have the following inputs and outputs. For inputs, we'll use a date and the weather prediction on that date. It's just a string, though the date and times will use specific data structures or inbuilt data structures in Java. And there will also be the first appointment time when the first appointment starts, and time when the last appointment ends on that date. The output will be a string with one of the following sentences. Please take the so-and-so train to go to the city, and so-and-so train to get back home on a given date. Or it'll be please drive on a given date and leave the house at that given time. Or it'll be please cancel or reschedule your appointments on the given date. Here is an example of what it should look like. Remember that we're not implementing it at this point. I'm just showing what the inputs and outputs should look like. So here's the prototype or the signature of the method that we're going to write. It has a date. Note again, this is probably going to need to be changed to an actual local date object. But for demonstration here, I'm just using a string. And so because March 9 is a Saturday and it's snowy, we cannot take a car. And also because the last train is at 10 p.m., we cannot take the train. So the output should be please cancel or reschedule your appointments on 2024 March 9th. Here, for example, a couple of days later on March 11, it's raining. And we have appointments from 3 p.m. to 10:45 p.m. So it's a Monday, and the last train is at 10 p.m. So we assume the train will run even if it's raining or snowing. So we say please take the 2 p.m. train to go to the city and 11 p.m. train to get back home on 2024 March 11. Now, in an actual system, we could build it so that we could check the schedule of the train on that day if there are any announcements using an API to the city's website or something like that. And also we could get the weather based on the date, so we don't need the train schedule, or the train schedule could be dynamic and the weather could be fetched from a weather service. But for now, we're going to input that and assume the train schedule. So we're not inputting the train schedule. So when we're looking at requirements like this, it's going to be fuzzy, and this is deliberate to an extent, because we want the student to get the feel of how it's difficult to gather requirements in the field and how it can be ambiguous when someone tells you requirements, and you need to actually write out examples to agree on what the requirements are. And if the requirements start to become too complicated, maybe you want to kind of iterate and build a first version where the requirements are tractable, and then keep improving on it rather than trying to get the requirements 100% perfect the first time round. Here's a fun requirements cartoon that's popular on the internet. As you can see, as the customer explained it and how the programmer understood it can be drastically different. So until you build the program and the customer starts using it, I think it's all going to be fuzzy by the nature of it. It's very difficult to communicate exactness of requirements. Let's get actually started in building something, and then we can start to refine it. So to get started, we'll first decide how we want to write the program, kind of top down, like a plan on approach of writing the program. And we'll use this concept called decision trees. So there are a couple of videos that I recommend to get an introductory sense of what decision trees are. Here's one by Smart Draw that just talks about how they could be used in finance, project management, and all sorts of different things. I highly recommend that. I'll put a link below. And also this one talks a little bit more about how decision trees could be created from data. This is by Mishra Terp, and this is a really great video explaining how decision trees can help you in complex situations where you have data, and how you could use machine learning and data processes to backtrack decision trees based on data. But what we'll be doing is drawing our own decision tree and then implementing it in Java. So we'll go through the process, the thought process there in the next section. So we'll plan to do this in a two-step process, where in the first step we'll build a decision tree, leaving some of the details of the output undefined or to be filled in. And then in the second step, we'll go in and calculate the details of what we need to fill in. So let's first get started with the decision tree. At this point, I encourage you to watch some of the decision tree videos that I posted below, and then attempt to solve this yourself. Pause the video and attempt to solve this yourself before looking at my solution. So looking at the requirements, I see that the decision whether to take the train or to drive or to cancel the appointments could depend on whether it's raining or snowing, because when it's raining or snowing, I prefer not to take the car. I'd rather reschedule the appointments. And also, if the appointments are such that I will not be able to take the train because I'll miss the appointments between the first and last train, then I will need to reschedule the appointments. Otherwise, I'll take the train. So if the train is feasible, then I'll take the train. If it's not feasible, then I'll have to decide between whether to drive or to cancel the appointments. So that's not the only way we can do it. Here's another example from some class exercises that we did. So you could first decide the weather and whether it's the weekend or the weekday, and then draw the diagram in a little bit more detail about when to reschedule, when to take the train, and which decision do you want to make first? Which input do you want to look first? You want to look at the time of the first appointment or the time of the last appointment, or do you want to look at the weather first? So that's kind of determines what your program will look like. here's the diagram. I'll be using those as a reference to actually write the program. Now this is very similar to the one I drew before, where to check whether the train is feasible or not. So whether the train is feasible or not actually just depends on the timing of the appointments, and then if it's not feasible, whether we drive or reschedule depends on the weather. We'll first start with writing doing this using test-driven development methods. So let's start with a stub. I'll start from blank so that you can see me typing, that it's not difficult to actually type this out. So let's name the class My Travel Planner. We'll have a main and see that we have a blank class here. So over here, because we need the inputs, Java, so actually we don't need the main, so we'll just say public string get plan, and we'll say return to be implemented. Now in the plan, we need an input of date time, the date of plan. So let's say date, local date, date of plan, and then string weather and local time, time of first APPT appointment start, and local time, time of last appointment end. And then we'll import local date and local time so that we don't need to type the whole thing each time. So we'll just have this in the travel planner, and we'll first start writing unit tests for this. So if we say new JUnit test case, if you don't see this right away, you might have to do other and then go to Java and go to JUnit and say JUnit test case, say next and say finish. And I'm doing this in JUnit 5, so if you're doing this in an older version of JUnit, then it might look slightly different. So when you do this, if you have available, please install JUnit 5 so that you can follow along. So over here, now let's do a basic test. Let's make sure that first that I can run this test. I'll right click here and say cover is at JUnit test. And the way that I know that it ran is that it'll say there were 1 runs, and it has a 1 failure over here. So let's put in some example tests, or start to put in some tests. So what we'll do is each time we want to test a particular type of plan, let's say weekend train feasible 001. We'll just name this test 001, 002, etc. And then over here, let's say my travel planner planner equals to new my travel planner. So we create a planner object, or a travel planner object, and then we will say the conditions. So let's say let's do again the date time, or actually local date, date of plan. So now how do we create a local date object? So if you haven't had a chance to look at documentation for this, let me show you the documentation for this a little bit. So, and when I search for Java local date, you'll see that you'll get a little bit of a documentation here. I usually look at the Oracle one because that's the official one. And over here they have this thing called auth, from which if you have the year, month, or date, then you can create a local date object. So we'll use this notation to create the local date object, local date.auth. Let's say 2024 March, let's say 11. And I think we looked at it before that. Let's see, I think I had some examples here in the other place. Oh, actually March 9 was a weekend, so we'll try March 10 because that's a Sunday. And then let's say let's put in a weather. Let's say sunny. It doesn't really matter. The weather should not matter for when the train is feasible. So, and then the time, local time, date or time of first APT start. Let's say, and local time has a similar construct. So let me also import local time and local time dot auth to create local time objects. We have hour and minute. So let's say, and I think this is in a 24-hour format, but let's say that since our first train is around I think I said 10 a.m. So let's put it at noon. So 12, and let's put our appointment at 12:15. And let's say the last appointment is ends at 3:45. And actually this is 3 p.m. So we'll add 12 to this, and we'll say last APPT end. So what should be the expected plan here? Expected plan is equals to, I think the format for the plan is please take the so-and-so train to go to the city, and we'll copy the format for the plan here, and we'll say over here, please take the so to get there at 12:15, I think we have to take the 11 a.m. train. 11 a.m. train, because if we get the 12, then we'll get there at noon, and we have a buffer of 15 minutes. And if our appointment ends at 3:45, then maybe we could take the 4 p.m. train back on March 10. So that is what we'll be aiming for. And then let's see, we'll get the actual plan. Make that a little bit smaller. And make this, maybe I'll make this a little bit smaller so that I can make the font bigger and still see this. So actual plan. So actual plan is planner.getPlan, date of plan, weather, time of first, time of last appointment. And what we want to do is to assert equals. I think when it's a string, it does the right thing. So expected plan and actual plan. So if we run this right now, it should fail because we don't have it implemented yet. So if we run the test, taking a little bit of time here, and it failed. And if we look at the details of this, so say please take the expected is please take the 11 a.m. train to the city, but the actual is to be implemented. That is to be expected, since, or that is what we have currently, since we have not implemented this. So in test-driven development, what you want to do is you first want to create a whole bunch of tests, and then only implement the program, so that if you then change the requirements, you can go back and change the tests a little bit. And if the requirement only changed by a little bit, or if you found a bug and it only affects a part of the program, you think, but when you fix the bug, if it invalidates another thing. So sometimes when you fix something, it breaks something else somewhere else. So having these tests beforehand will make sure that when you fix something, you always run this test whenever you make a change, so you make sure that you are not breaking something else that was already working before. Or if you make an overall change to the program, even the architecture, then if you have the tests, then you can check that you did not completely mess up the program. So let's add a few more tests. I'll just copy this over here. Maybe I'll add one that is kind of on the border, where I'll need to take the last train. So maybe I'll need to take the first train and the last train. So I added a bunch more tests to this over here, covering different conditions. For example, rainy early appointment. So because it's rainy and it's too early for the train, I'll need to cancel or reschedule this appointment. And then there's another case for a snowy case, and there's a weekend and weekday case where it's kind of borderline. So we just missed the train, so we need to cancel or reschedule. And there are some where it's feasible to drive. The train is not feasible, but because the weather is good, it's feasible to drive. So after adding a whole bunch of test cases, we still don't have anything implemented here. I encourage the student to add even more, like about 20 different test cases before they start working on the code. But let's see that it actually, there's no syntax errors or things like that, and everything runs. And we should have 8 failures here. So so we have 8 failures, no errors. That's what we want. And if we look at any of these, it would say that's the expected and the actual is to be implemented. Now we'll move on to actually do the implementation. So again, this diagram is what we'll refer to when doing the implementation. So let's start out with writing the code for what we want to do when the train is feasible, and then what we want to do when the weather is good or bad. So we'll do this thing called top-down programming, where we won't get into the details, and we'll do the high level first, and then we'll implement the details as we go. So over here, let's say we'll start writing here, and let's say if train is feasible, and so to determine whether train is feasible or not, I think we don't need the weather, we just need the date of plan, we need the time of the first appointment and time of the last appointment. So if train is feasible, then we will say return get train plan. So to get the plan, again, I think we only need these three. The weather is not required. And since it's a single liner, I'll even remove the block. So right now, we don't have these methods yet. So we will hover over this and say create method. So it created a private method with all the right things there. And by default, it's returning false. And say get train plan, and get train plan should return a string. So that over here so we can see more. So else if train is feasible, then maybe the weather is good or not. So weather is good. So to determine the weather, we actually just need the weather. Or maybe in the future, we could connect it to a weather API and get it from the date and time. But for now, the weather is input here. And we will say return. So if the weather is good, then it's the car. So we're going to be driving, and we'll say get car plan. And to get the car plan, I think we just need the time of the first appointment, because the way that we've specified this, again, there could be ambiguity in the requirements, but we just need to know when we need to leave the house. We don't need to know when we need to return. So we just need the date of plan and time of the first appointment. Otherwise, we will reschedule. So reschedule plan. So reschedule. To reschedule, we don't need any of this actually. So we just need the date, because we need to mention the date, I think. So please cancel or reschedule on. So we need the date to kind of create that output. So let's create all these stops. Weather is good, car plan, and reschedule plan. So which of these might be easiest to implement? Let's say weather is good should be easy to implement. So let's do that first. Let's say return weather dot equals. So remember, in Java, you can't do equals for string, because that checks that they're exactly the same object and not that their value is equal. So we'll do weather dot equals cloudy. So now we have the weather. Maybe if we it still should run and have 8 errors here, or 8 failures. Let's see. So yeah, 8 failures. None of these are complete yet. But I think the easiest one to do next might be the car or the reschedule. I think if we do a reschedule, a bunch of these should start passing. Let's say reschedule. So over here, now we want to do return, and let's get the template for reschedule. Here. So now here's the somewhat interesting bit, probably, is this part. We don't know how to format the date yet. So let's put in a string here and say formatted date equals to format date and date of plan. And again, we are doing top-down design, so we're not worrying about the details until the last moment, or until we get there. And then over here, we'll just say plus formatted date, and then we'll again implement this separately. So we could have done it right here, but because we may be needing this for other parts of the program, if we put this separately here, then we won't need to redo this. So now to format the date, let's look at again the local date for Java. There must be a date formatting thing here, and if we kind of look at this carefully, let's say format. So format uses a date time formatter, and there are different format strings that we can use. And if we look at this one kind of seems close to what we want here, or maybe we'll need to look at the details here to get exactly what we want. So the way to do it, the template code is something like this. So if we say that date time formatter, and then we'll hover over this and import date time formatter, and then we will say string. Yeah, now so let's also change this to date, so that we have this is just format date, and then let's say this is the formatted date. So we have the pattern, and we will return text. So some of them, these now should just start to pass. Let's see if we run this, and let's see, maybe we can car early appointment, means that we might need to reschedule. Please cancel or reschedule appointments, and it's just the formatting is now not exactly the same. So we needed October-08, we got 10-08. So over here, what we could do to change the formatting is to first change this to dash and dash, and then we could also put a full stop or a period at the end. And then let's look at the documentation again to see what might give us the month in a 3-digit month type output. And if we say just 1M rather than 3 M's, that might do it. Or let's see if there are other things over here to whether we need to put 3 of them or 1 of them. So let's try M to see what happens. The documentation is not exactly clear on what is required to get this kind of the output, but let's see if there's more examples here. And if we look at this one, near the N, I'm still getting a 2-digit month there. So let's try MMM to see if we will get some kind of a full month over there, or the three-letter month. So now 2 of them actually passed. So I think that's all the scheduled appointments actually passed when we did the 3-letter month. So now let's try the car one, because I feel like the car one is a little bit easier. So to get the car plan, what you need is you need to say what time that you want to drive. So let's take the template from one of the test cases we built, or from the requirements actually. Say return, and we will this time maybe let's do string dot format. We'll say please drive on %s and leave the house at s. We will use so for this one we just need the format for format date and date of plan. For the second string, what we need is, we haven't made that yet, but let's say format time, and time of first appointment start. Maybe I didn't copy it exactly, so time of first appointment start, and then we can create such a method. So over here now, to format it, I think the general way to format is very similar. You create a formatter and then you return the text. So over here we'll call that time instead of date, and time and formatting. Now the way we've written some of our test cases, and actually this could be ambiguous, but we assume that we asked our client and they want or the product manager, and they want the output in this format. So let's see how we could get AM PM. So AM PM is A, we'll get AM or PM. So the formatting at the end has an A, and then we need hour of the day in a 12-hour clock format. This is H. So H gives you hour of the day. H gives you hour of the day, and then we'll put a colon here, and then minute of hour. So minute of the hour, if we put M, then maybe that gives us the minute of the hour. Now it's not clear whether if the minute is 5, for example, less than 10, whether it'll give you 0, 5 or just 5. Now let's make sure in our test that we have examples where it actually needs to say 0, 5. Let's say over here, maybe some of our train examples. So there's nothing that has the case where we need, for example, over here, if it's a whole number, then we actually don't need the colon 0, 0. So that will be a special case. So let's maybe let that fail and then implement it again. Okay, let's make this one a little bit dependent on whether the minute is 0 or not. So let's say if time dot, let's say if there's a get minute, get minute is 0. Then we will say, let's add a string called pattern. And pattern, I'll put it even in the same line because short and sweet, H and A. Else pattern equals to, let's try the HH. I think we don't do 0, 8, we just do 8, so HH MMA. Let's see if that works. Then we'll replace this one with pattern. See if any more of the tests pass. So we have only 3 tests passing. Let's see what's up with the car. So please drive, that one's passing. So leave the house at 7:45 is expected, but we say 8:45 a.m. Otherwise it's good. So I think we forgot to account for the 1 hour travel time. So let's actually create a constant for travel time over here. Say public static final int travel time minutes equals to 60. So we have 60 minutes of travel time, and when we get the car plan, we need to subtract 60 minutes. So I'll say, let me put that one line below and say dot minus minutes, travel time minutes. That might do it. Let's see. So when we run this, we should have at least one of the car plans passing. We have both the car plans passing. Now we have a bunch of these passing, but we don't have a test where we have something like 0.5 to test that it will print out like 5 minutes correctly, and it won't say 9:5 and it should say 9:05. And also we may not have for the car test cases where it's exactly 9 p.m. for example, or 9 a.m. So let's add some test cases here. Let's see where my test cases are. It's here. And we will add, I'll add to the car test cases. Let me do one really early in the morning. Let's see, let's do 6:22 and cloudy, and we will say the first appointment is at 4:05, so we have to leave at 3:05. And let's make this one a little bit more tractable, like 8:35. That shouldn't matter. And then so say please drive on May 22 at 3:05 a.m. And now we should have this case also passing. Let's add one that has that doesn't have the minutes, or the minutes are 00. So over here, let's do 23. It shouldn't matter whether this is a weekday or weekend because we're doing it very early in the morning. Let's call this just the car, and we'll do it exactly at 5 a.m. So we will need to leave the house at 4 a.m. Okay, so when we run the test cases, we have the car 10 is not passing. So car 9 is passing, but we have some issue with car 10. See, oh, okay, I think this is just the wrong test case issue because we changed April here. Say April 23, and run the test cases again. And now, let's see, car 10 is also passing. So now let's add some test cases where we need to leave the house in the late evening. So let's see, we'll call that car 11, and let me do January 1st. Maybe 2020, and let me do 23:01 is when the appointment starts, and 23:55 is when it ends. So let's say 2020 then 01 and leave the house at so this is 10:01 p.m. Let's see if this one provides any additional defects that we need to fix. And test car 11 also passed. So while we're at it, let's add one. It's probably, let's say 12 a while back. Let's say 1920, and this is exactly 00, exactly 00, and 1920 way far in the past, and 10 p.m. Let's make that sunny, and if we run that, that was passed. So now the only thing remaining is the little bit more complicated part that we left for later, is to get the train plan. The reason this is complicated is that it's not just directly subtracting the travel time. You should be subtracting, or you should be catching the train that leaves enough buffer time before your meeting start. And then you also should calculate the return train, so after your meeting end. So we'll assume something like there's no buffer needed. So if when you take the catch the return train, because what you could do is you could leave, let's say 5 minutes early, and we'll assume that the train station is right next to where your appointment is for simplicity. Now later you could imagine putting in more exact address of the appointment, and then calculating travel time, calculating more details based on that. So let's get started on this one. So before you look at my solution, I encourage you to try your own solution. Think of what you do, or at least take maybe 5 minutes to think about how you would tackle this. And then you can continue the video to look at my solution. So the way I want to tackle this is to first calculate all the times of the train on a given date. And then from there on, we can look at which train we need to catch to go to the city, and which train we need to catch to come back. So if you can imagine, for example, the trains are every hour, then we'll, or if they're every half an hour, we'll generate the schedule of the trains. And then we'll look at the time that allows for the travel time, as well as, you should reach there before the appointment, and you should leave the city after you finish your last appointment. Okay. So we'll start out again with a top-down approach where we'll say we'll get the plan, and then when we get the plan, we'll get the schedule and we'll see how it fits, and then we'll return that. But then getting the details of the plan, etc., we'll leave that to later. So looks like we haven't implemented is train feasible yet. So let's see, how did we get past this over here? So because we're dealing with only the is train feasible false case, that's why we got past this. And to figure out if the train is feasible, I think it'd be good to have the first train and the last train. So I think we had a diagram about this. Yeah, so here's the diagram. The logic is depending on whether it's a weekday or the weekend. We would choose like the 7 a.m., 11 a.m., 11 p.m., 10 p.m. It begins after X and before Y. So even though it's 6 a.m., we have to check for 7 a.m. because of the travel time. So let's implement this is train feasible, and we'll do it in a top-down way. We will, or maybe we also need to check if it's now it's time to dig into a little bit more details, so maybe we'll start doing it this way. So let's see, is weekday and it's weekend. So if it's the weekend, let's say time, local time, T1, we'll call it T1 and T2 equals to. So if it's the weekday, then we will do 7 a.m. Otherwise, if it's the weekend, we'll do 11 a.m. So we'll say if is weekend, date of plan, T1 is equals to local time dot off. So in the weekend we want 11 a.m. 11 else, or let me put local time T1 and T2, and we will say T1 is equals to that, and else T1, we'll line it up here, T1 is equals to local time dot off 7 a.m. And then similarly we want to do T2 also, so let's actually do this in a block. T1, T2 is equals to local time dot off, so weekend is 10 p.m. So 10 and because it's p.m. we'll add 12. T1, T2 is equals to local time dot off, and it's p.m. 11 p.m. So 11 p.m. so we'll add 12. this so everything kind of lines up. Then let's add a stop for this, and so it's feasible if appointment begins after X and last appointment ends before Y. So return so time of first PT start dot is after T1 and time of last appointment end dot is before T2. Yes, so I think that should give us feasibility. And then how do we check for the weekend? Let's say I think local date as a day of week. Data plan dot day get day of week as a day of week. Day of week. Day of week equals to day of week. And let's see if I can import this. Imports out of time day of week, and we will say if day of week dot I think we can just do equals day of week dot Saturday or day of week equals day of week dot Sunday. And if that's true, if that is true, then it's true, otherwise it's false. So that should be is. So that will tell us if it's the weekend, and if it's not the weekend, then it's the weekday. So now we have is train feasible, that's implemented properly rather than just always saying false. Let's see if all our test cases still pass. So we have 3 failures out of 12. Let's see, after we do this, we still have 3 failures out of 12, because if this one, is train feasible, returns false in the right places, then that will still be only 3 failures. So that's good. We exercise this part of code. Now we need to actually get the plan. So to get the plan, we will store the using the approach that we discussed before. We'll generate the schedule of the trains for a given date. Again, an extension could be to actually look at the local train API or website and get the actual schedule if there are delays, etc. But over here, we'll generate it based on just whether it's the weekday or the weekend. So we will say we'll have an array of local time, and we'll call it train times equals to get train times. And to get the train times, we just need the data plan, and then now we have train times. We'll need to check with an offset if the time of first appointment start is so we need to get there before the first appointment start. So we'll call that time, let's call that time T1. So local time T1. So again, that's a different T1 than this T1. because we are in a local context, so we'll reuse that variable. We'll say time of first appointment start dot minus minutes and travel time in minutes. So what we need to check is that T1 is before a given train time. So we'll check from the end. If we take the first train, it's always feasible, but we're wasting time. So let's see over here. If we need to get there by 10:15, we could take either of these trains. We could take the 6 a.m. train, we could take the 6:30 a.m. train. We could take any of these trains. But what we want to ideally do is to take the train that will just get there a little bit ahead. I know trains get delayed all the time, so we probably want to take one before, but we'll deal with that complexity later, depending on how reliable the train is and how important the appointment is. But over here, we will scan this array from the bottom up and pick the first time that is feasible. So let's say 4, and also to get rid of this underline, let me create a stub for this, create method. So, and we'll deal with that later. We'll say train times, we'll say time to, let's say local time, train to city is equals to train times. We'll take the last one, train times dot length minus 1. That's the last train, and then we'll say for I equals to let's say train times dot length minus 2, or maybe we'll start with minus 1 and then allocate all of this inside. Say int, and I is greater than equals to 0, I minus minus, so we're going reverse in the array of train times, and we'll put this one inside of this. So let's check if this is feasible. So to check if this is feasible, what we'll do is if T1 dot is before the current one, we will say train times I, then we will set train to city to that, and then else. So now if this is not feasible, we'll leave it. So this one will start out as null because we did not assign any object to it, and when we get a feasible one, we will assign that feasible train, and as soon as we find a feasible train, or actually let's do it the reverse. So maybe we can start from the top, because it's likely that we'll not need to traverse all of this. So if we start from the top and we continue until it's feasible, and if we find that it's not feasible, then we will break out of this loop. So then the last one to be set is the one that is feasible. So let's see if this is still makes sense. So T1, let's say dot is after, would probably make sense more. So T1 in this case, 10:15 minus 1 hour. So it's minus 60 minutes, so 9:15. So 9:15 is after 6 a.m. So it's still feasible. So I think we also need to reverse the loop here. We'll start with 0 and go to length minus 1, I less than train times dot length, and I plus plus. And if T1 is after the given train time, then we will set that. Let's say T1 is 9:15, it's after, but over here it's no longer after, so it's no longer feasible. So we should stop at 9 a.m. And then we'll do something similar for the return train. So local time T2, and we'll just do the logic in reverse. And in this case, we don't actually need to add the time, because when we return, we'll assume there's already a little bit of buffer, and we can get to, if for example, if the train is at, for example, if we need to take the 10:30 train and our appointment is exactly at 10:30, we'll assume that maybe we can, maybe it's a dinner and we can say, oh, I need to catch the 10:30 train and leave however minutes early, like 10 minutes early from the dinner table. So we'll make some assumptions there, and let's see over here how that logic could work out. For int I, we could keep using I. We'll use another variable z, and this time we actually need to go from reversed train times dot length minus 1 and z greater than equals to 0, z minus minus. See, maybe did I misspell this? Train times, time times, okay, train times. And if let's say time of last appointment end is before train times, let's say we'll create another train back. So this one closes that. Train back equals to train times, say, I like shorter lines of code, so let me actually make it like this. Again, I think I misspelled this. Train times else break. Let's see if that makes sense. So if we say train times, say we need to take the, say our appointment ends at 10:30, then 11 p.m. So 10:30 will be before 11 p.m. So we'll set that, and then we'll go to the next one. And 10:30 is, so it won't work with exactly 10:30. So there should be at least 1 minute of buffer, it seems, using this logic, and we'll just leave it to this logic. And then 10 p.m. will no longer be is before. So this will be 10:30, this will be false, and we will break. So that seems to be correct for me. Let's see, so this one's complaining a little bit, so we may need to initialize it to appropriate values, but we'll leave it to that at this point. And let's get the template of what it should say. Let's try. I think one of the first examples is a train example. And it should say something like that. And we'll say return string.format, and that will be the format. Now this one we'll leave it to %s, and this one we'll leave it to %s also, and this one we'll leave it to %s also. And we will say, so the first one is format time, and that is train to city. And the second one is format time, train back, and third one is format date of plan. So let's see, train to city may not have been initialized, so we will need to force an initialization here, even though it actually is initialized. So train times 0, and we'll say train times dot length -1, and then because we already initialized it to the first train and we already checked, by the time we get here we already checked for feasibility, we could start with 1. We don't need to check that again. And this one we could start with -2 because we already initialized it to -1. And all that remains to be done is to get the train times. We will say, so we'll do something similar like is weekend and is and then interval will be interval start and end will depend on whether it's the weekend or weekday. So we'll say local time t start, t end, or we'll say t first, t last, and then interval will be minutes, interval minutes, and if we'll say is weekend, is weekend date of plan, then t first equals to local time so off will be 6 a.m. T last will be 11 p.m. 11 plus 12. Let's do this, something like this. Let me do 12 plus 11. And then interval, or actually in the weekend it starts at let me see over here. Yeah, it starts at 10 a.m. and ends at 10 p.m. and it runs every 2 hours. So interval equals to, let's say, 10 a.m. and 10 p.m. Interval equals to 120 minutes. Otherwise, we'll have this one to be at 6 a.m. and 11 p.m. and interval will be 30 minutes. And now we need to calculate how many so to create an array, if we instead of using an array, if we use an array list, then we don't need to calculate beforehand how many we need. So let's actually do ArrayList of local time. I think that's allowed. Let's say import ArrayList, and we'll create an ArrayList of local time as train times equals to new array list of local time. And then, so we'll start with, let's do maybe a while or do while loop. So local time, a train time. So we'll start with the first one, and we'll say while a train time dot is before t last, we'll add it to the train times. Add a train time, and we will also need to add the last one. So train times dot add t last, and over here some error here. Return, let's say train times, and we'll increment a train time. Train time dot add, let's see if it has a add minutes. Minus, so maybe there is a plus minutes. Minutes, and let's see if it actually changes the object or returns a new object. So I suspect that it'll return a new object. Local time Java, and if we look at add, that's probably an instance method. Add minutes. Let's see if it's in all methods. So this is not in minus minutes. Oh, actually it's plus minutes. Plus minutes returns a copy with the specified number. So it doesn't change the current object, it returns a new copy. So we have to replace this. A train time equals to that, and then so now because we are returning an array list, we'll have to do array list of that, array list of local time instead of an array, and then to get that, I believe the notation is, okay, let's say get first. Do a tab train times dot get last, and instead of length, I believe the notation is size, and instead of I believe it would be get of I. Get of I. And say is train times dot size, and so train times dot get, say and also the train times dot get. So that should be an initial version of the full implementation. Let's see some of these 3 test cases pass now, and then we'll debug. So taking a few seconds to run the test. So they don't pass. So let's see what's wrong here. So please take the 11 a.m. train to go to the city and 4 p.m. train to get back. So expected is 11 a.m. and the actual is 10 a.m. So now let's see what's up with this. It could be because we did is before and not is before or equal to. Let's see. The first one that failed. So our appointment is at 12:15, and because the trains only run every 2 hours, and this is actually the weekend, so it starts at 10, and then the next train is actually at noon. It's not at 11. So our test was actually incorrect, because in the weekend the trains run like 10 and noon, etc. So let's run this again. It could be maybe the next one has a similar issue. So train feasible 2, what's the difference between this one and this one? So did we actually not change it? Yeah, these two are exactly the same. So let's try one where we're actually needing to catch the last train, which is let's say the last appointment is 11 p.m. So let's do 11 p.m. and let's say 10:45 p.m. So we'll need to catch the 10 a.m. train, and actually it's only 10 p.m. I think. So we'll say 9. Let's do something like that. 9 p.m. 9:45. So we'll need to catch the 10 p.m. train. And this is March 10, so I suspect March 11 is also a weekend. So let's see, March 11. Let's run that. So this one's passing now, the first one. The second one fails. Let's see. So please take the 10 a.m. train to go to the city, and actual is 11 a.m. train to go to the city, and that's probably because March 11 is now a weekday. Yes, March 11 is a weekday. So let's actually do March 9, and March 9. We're testing the weekend. So we have this one passed now. So we have test weekend car is failing, and please drive on March 3. So test weekend car number 6. So, or maybe if I double click here, we'll see here. I think it's just this March 10. We did not change some of this, or I remember changing some of this, so maybe I put it in a different file. Let's say leave the house at 4:35. Yeah, that seems correct. So all of the tests passed. Now let's add some more tests. We'll do weekday, a bunch of weekdays where we need to take the 30 train, like 9:30, 10:30, etc. So let's say weekday, and let's call it 13. I'm just numbering these tests 12, 13, etc. just so that I get a count of things. And we knew that 11 was a weekday, so let's do 12. And let's say it's actually rainy. I forget whether I did raining or rainy. Let's see over here, it actually doesn't matter because we only check sunny and cloudy. And let's go back here. Let me close these other ones that I was demoing so that I don't get confused. And let's say I need to take the first train, which is the 6 a.m. train, so, or the 6:30 a.m. train, because if I have an appointment at 7:35, then I should be able to take the 6:30 a.m. train, and the last train, let's say, is 11. Let's say my appointment ends at 10:45. So then I can take the last train. Let me actually also line this up. Sometimes I like to line things up so it's easier to read. And take the 6:30 a.m. train to get there at 7:30, and then the appointment starts at 7:35. And then I need to take the, because it ends at 10:45, 11 p.m. train, and this is March 12. So let's see if that one passes. Yes, so we could add a bunch more tests, and for the students I asked you to add at least 20 tests here, so 7 more tests. And some of you also many times you want to add a main method to actually like see this running. That's also great. You could also create a graphical user interface for this, and then the other extensions you could do is to get the weather using an API rather than just getting it as input over here. And then once you start to get the weather from an API, you'll need to get weather, either past weather or weather predictions, and the predictions could change as you get closer to the date of plan. So thank you for staying this late into the video, more than an hour-long video, maybe after editing, maybe a little bit closer to 1 hour. Hopefully this is useful to get you started in software engineering, and in particular also the Java programming language. I'll see you next time.